Okay, welcome back to another video on the Maths channel. It's your teacher Miss Lim here, and in this video we're going to be looking at line symmetry and rotational symmetry. So by the end of this lesson you'll be able to identify how many lines of symmetry a shape has and identify the order of rotational symmetry a shape has. So let's have a look at the first part of this lesson, lines of symmetry. An axis, or line of symmetry, divides a shape into two equal parts. It acts as a mirror line, which each half of the shape being a reflection of the other. Let's have a look at a few examples. How many lines of symmetry do the following shapes have? And draw them in with dotted lines. So here in question A, it has one line of symmetry, because if we were to draw a dotted line right down there, that's the only place where when we fold it across that line, it will exactly cover the other half. So there is one line of symmetry. If I were to draw, if I were to draw the dotted lines this way instead, it doesn't cut it exactly in half, and when we fold it, it's actually not going to completely cover the other half. So there's only one line of symmetry here. Okay, that's down here. For this rectangle here, there are actually only two lines of symmetry. Two lines of symmetry. Where are they? Right down here and right across the middle section there. When we fold it along those lines, we can fold it exactly in half. Now you might be wondering, oh, what if we drew a line this way? If I were to fold it, wouldn't exactly cover the other half? Well, it actually wouldn't. This part, this corner here, when folded along this line, will come down here. It's actually not going to come across to here. So there are only two lines of symmetry. For the square, there are four lines of symmetry. Straight down the middle, straight across the middle, and the two diagonals as well. Now this one's a little bit different compared to the rectangle, because when we fold it along the diagonals, this time it actually will cover the other half completely. Right, what about question D, E, and F? I'll get you to pause the video, have a go with question D, E, and F by yourselves. Question D is an equilateral triangle. I'll just put the markings in so that you know that these sides are all equal to each other. And question F is a regular hexagon, so all sides are equal as well, because it's a regular hexagon. Right, pause the video, have a go. Okay, question D has three lines of symmetry. Straight down the middle. That way. And this way. When we fold along those, it will fold exactly in half. Question E, however, has zero lines of symmetry. Zero lines of symmetry because there is nowhere we can actually draw an axis a symmetry or a line of symmetry where it will fold completely in half. So you might have thought, oh, what if we drew a line like this? Unfortunately, that won't, when we fold it across that line, it won't completely cover the other half. Yes, it is split into two equal halves, but when we fold this corner here across this line, because it has to be at a right angle, it's going to come down here somewhere. It's not going to come over onto this side. So there are 0 lines of symmetry here. What about question F? Well, we can fold it right down the middle. That's 1. We could fold it right there, right across here. That's 2. And we can fold it right across here as well. That's 3. However, there's actually more than that. If I were to fold it from the vertices, right there, you see how that folds into two equal halves as well, and it will completely cover each other. So that's 4. Here's 5. And here is 6. 6 lines of symmetry. Okay, let's have a look at the last part of this lesson today, which is rotational symmetry. Now, the order of rotational symmetry refers to the number of times a figure coincides with its original position in turning through one full rotation or 360 degrees around its center. If the order of rotational symmetry is 1, then we say there is no rotational symmetry. So after rotating it one full revolution, if it only looks exactly the same after you've done the one full revolution, then it has an order rotational symmetry of 1. So what is the order of rotational symmetry for the following shapes? We've got 6 examples here, and I'm going to use my trusty Microsoft Word to help explain this. Here we go. So question A. I have the original shape on the left just for reference, and I've just made a copy of it to the right so I can see as I rotate the right one whether it will look exactly the same as the original one or not. So have a look up here. I'm going to click and drag this and just have a look to make sure when it comes all around, that's going to become one full revolution when I come back to the top. So let's start rotating it. Nope, still doesn't look the same, still doesn't look the same, still doesn't look the same, and now it does. After one full rotation, it only looks the same once, so it has an order of rotational symmetry of 1. Alright, what about B? Here we got a rectangle. So let's compare them. And click and drag this one. Not the same, not the same. Still not the same. That's 180 degrees. Okay, it looks the same. That's once. Doesn't look the same. Looks different, looks different, looks different, looks different, and looks the same. So after one full revolution, after coming all the way back to the top, it looks the same twice, so it has order of rotational symmetry of 2. Or we can say order 2. Alright, what about the square? Looks different, 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 different. Same. That's once. Different, 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 different. Same. That's twice. Different. Same. That's 3 times. Different. 4. 4 times. So a square has order rotational symmetry of 4. What about Question D, the equilateral triangle. Different. Oh, same. 1. Different. Same. That's 2. Different. Same. 3. Okay, so an equilateral triangle will have order of rotational symmetry of 3. What about question E, this parallelogram? Different. Same. That's 1. Different. And then the same. That's twice. 2. And last one, question F. We've got a random shape here. It's all different. Oh, it looks exactly the same. That's 1. All different. And then the same. So it has 2. Okay. So out of the 6 shapes that we've looked at, one of them has no rotational symmetry. And that's question A, right? When the order of rotational symmetry is 1, we say there's no rotational symmetry. The only one out of these 6 is A. Of course, that's not the only shape with no rotational symmetry. There are many other ones. It just so happens in these 6 examples, that was the only one. Right, so now you know how to find and determine how many lines of symmetry a shape has and what order of rotational symmetry a shape has. Thanks.